Ever feel like we're just drowning in data these days? It's everywhere, right?
It really is.
But have you ever stopped to think about how it's actually organized? Like all that data, how do we even make sense of it?
Yeah, it's more than just ones and zeros.
That's what we're diving into today, the fascinating world of database storage models.
We're going way beyond just the surface level today. We're uncovering how the actual structure of that data, how it's organized, shapes what we can even do with it.
Okay, so let's start with what we already know. We hear about data all the time, but what's the framework, like the basic structure for understanding it?
Think of it like a massive library, right? You got rows and rows of shelves.
Okay, I can picture that.
Each one is packed with books. Those books are your data points.
Right.
Each book has its own little card in the catalog.
Right.
Title, author, all the key details, those are your columns.
So that's our classic spreadsheet setup, rows and columns. Seems pretty straightforward.
Exactly, and that's your row-based model. Relational databases, those are built on this MySQL, PostgreSQL,
Those are familiar names.
and it makes sense, right? When you're buying something online, you need to access your specific order information, and you need it fast.
Yeah, absolutely.
Row-based models are great for that individual transactions.
Makes sense. Speed and efficiency for those everyday tasks. But what about when you need to analyze mountains of data, not just one person's order?
Right, like think about analyzing buying patterns to
Mhm.
try and predict what people are going to want next holiday season. You need a way to look at trends across millions of customers, not just one person's purchases.
That's a whole lot of data.
That's where column-based models come in. It's like scanning an entire library shelf at once, looking for a specific keyword instead of having to go book by book.
So instead of focusing on one person's entire shopping history, we're looking at everyone who bought, say, I don't know, a certain sweater.
You got it. Systems like Cassandra, Amazon Redshift, they excel at this. They group data by specific attributes, customer demographics, purchase history, you name it.
And that makes them good for one.
This makes them incredibly powerful for things like business intelligence, scientific research, anything that needs to process and analyze huge amounts of data quickly.
So we've got rows, we've got columns, both super useful depending on what you're trying to do with the data. But are you telling me there's more to this data organization story?
What if we're not limited to just rows or R columns? What if there's a way to see not just the data points themselves, but the connections between them?
Now that's an intriguing thought, like how all those different data points actually relate to each other.
Precisely. That's where we enter the realm of network-based models, or graph databases, as they're often called.
Okay.
Imagine a web of interconnected data points, where each point is like a star in a constellation, and the lines between them, those represent the relationships.
A web of data points, that sounds incredibly complex, but also incredibly powerful, right?
It is powerful, and it's really well suited for understanding things like social networks,
Social networks. Okay.
how people are connected, how information flows, or even like recommendation algorithms.
Yeah.
Like those suggestions you get on, shopping websites or streaming services, those are all about understanding those relationships within the data.
So if those relationships are so important, how come we haven't always been using this network-based approach?
Well, traditional databases, right? Those row and column structures.
Right.
They weren't built to handle this level of relational complexity. Think about trying to understand, like, a family tree just by looking at a list of names and addresses.
Okay, yeah.
You would be missing all those, like, crucial connections that tell the real story.
You're right. It's those connections that reveal the bigger picture. So tell me more about these graph databases. Are there like specific systems that are designed for this kind of analysis?
Absolutely. Neo4j is a popular one, and Amazon Neptune is another.
Okay.
But, our source material today highlights a really interesting platform called FalkorDB.
FalkorDB. I mean, the name alone just sounds cutting edge. So what makes this one stand out from the crowd?
It's all about how FalkorDB tackles the challenge of representing those relationships, those crucial connections between data points.
Okay.
And it does so in a way that's incredibly efficient.
Okay, now you're talking my language efficiency. But how does it actually work? This is where I usually start to get lost in the technical weeds.
Sure. Let me try an analogy. Imagine a city map.
Okay, got it. City map.
Traditional graph databases, they might represent those connections between different locations as a series of lists.
Okay.
Point A connects to point B also connects to C and D, and so on.
I can see how that could get messy and complicated really, really quickly.
Exactly, exactly. But FalkorDB leverages something called adjacency matrices.
Adjacency matrices, okay.
Instead of lists, imagine a grid where each intersection represents a potential connection.
Okay.
It's like having a direct route between any 2 points on the map, making navigation lightning fast.
So instead of taking the scenic route through a bunch of lists, you've got a super highway to the information you need.
Precisely. And that speed, that efficiency in navigating those relationships, it unlocks incredible potential for analysis and discovery.
A data superhighway. That's a fantastic way to put it.
Yeah.
But give me an example. How does this play out in the real world?
Okay, let's say you're trying to detect fraud.
Okay.
With traditional databases, tracing a series of suspicious transactions across different accounts and locations could be incredibly time-consuming.
Yeah, I can imagine, for sure.
Like trying to follow a trail of breadcrumbs in a hurricane.
Right.
But with FalkorDB, you can see that entire web of connections instantly. All those seemingly separate events suddenly become part of a much larger pattern.
Wow.
It's like having X-ray vision for your data. You're revealing hidden connections that would have been impossible to see before.
So it's not just about speed then, it's about uncovering those aha moments, those hidden relationships that lead to breakthroughs.
Exactly. And this has huge implications for fields like cybersecurity, where understanding attack patterns and relationships is absolutely crucial, or drug discovery, where you're analyzing those complex interactions between molecules and proteins.
This FalkorDB system sounds incredibly powerful, but it also sounds like something that only, hardcore data scientists would ever use.
Well, it's true that FalkorDB is a very sophisticated tool, but its impact, it extends far beyond the realm of, just data science. Think about those personalized recommendations you get on your favorite streaming service.
Okay, yeah.
Or those instant fraud alerts from your bank.
Right.
These are all powered by sophisticated data analysis that's made possible by these advancements in database technology.
That's fascinating. I never really realized how much these behind-the-scenes innovations actually influence our everyday experiences.
It's easy to take for granted, right? But understanding these different ways that data can be organized, it helps us appreciate the possibilities, the limitations, and really the potential for innovation. It's about becoming more informed consumers and creators in our increasingly data-driven world.
You've given me a whole new perspective on something that, frankly, I interact with every day but rarely think about. We've covered a lot of ground in this deep dive, from those familiar rows and columns to this fascinating third dimension of network-based models.
And who knows what other innovations are just around the corner, right?
Yeah.
What other hidden connections are we going to uncover as we continue to explore this vast, vast world of data?
That a thought-provoking question, and I think we'll leave our listeners with that image. A universe of data waiting to be explored, with new dimensions constantly revealing themselves. Thanks for joining us on this deep dive.